everyone. Myself Sravanthi, working as the assistant professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today my topic is ambiguity. So here we are going to discuss what is ambiguity, what is ambiguous grammar, and what is unambiguous grammars with examples. So first let us learn what is ambiguity. Ambiguity is nothing but here the context-free grammar is divided into two types. A context-free grammar is nothing but it consists of four tuples, nothing but we can call it as quadruple. It consists of G is equal to V, T, P, S. So nothing but a context-free grammar consists of variables, terminals, productions, and start symbols. The variables are nothing but the non-terminals and the non-terminals. The non-terminals are nothing but the capital letters. The non-terminals are nothing but the capital letters, and T is nothing but it consists of terminals. It consists of terminals, nothing but small letters, and P is nothing but the production rules, and S is nothing but the starting symbol. So the context-free grammar is consisting of these four tuples. This context-free grammar is divided into two types, that is nothing but ambiguous grammar and unambiguous grammar. So what is ambiguous grammar? Ambiguous grammar is nothing but if there exists more than one parse tree. I can tell is more than one parse tree. Nothing but if we can derive a parse tree using the leftmost derivation and rightmost derivation. If we are going to get more than one leftmost derivation or more than one rightmost derivation, and I can also tell that more than one parse tree it is going to generate, then we are going to call it as ambiguous grammar. So nothing but for the same string. Let me tell you, suppose this is my string AAB. So this string is generated with more than one parse tree. By using more than one parse tree, I am going to generate the same string. Then I can call it as a ambiguous grammar. So either it can be by using leftmost derivation or it can be rightmost derivation. I am going to generate more than one leftmost derivation or more than one rightmost derivation or more than one parse tree. Then we can tell that it is a ambiguous grammar. So coming to here, unambiguous grammar. An unambiguous grammar is nothing but if there exists only one derivation tree or parse tree, then we can call it as unambiguous grammar. So vice versa of ambiguous grammar. So for this string, I can generate only one leftmost or only one rightmost or only one parse tree. If I am going to generate, then I can tell it as ambiguous grammar. For the same string, I can generate only one parse tree, then I can call it as a unambiguous grammar. Coming to ambiguous grammar, if we can generate more than one parse tree, more than one leftmost derivation or more than one rightmost derivation or more than one parse tree, then we can call it as a ambiguous grammar. So here the derivations will be having leftmost derivation and rightmost derivation. We are going to construct for the parse trees. Okay, so unambiguous grammar is nothing but if we can generate only one leftmost tree or only one rightmost tree or rightmost derivation or only one parse tree we are going to generate, then we can call it as unambiguous grammar. So let us see here one example here. X produces AB. So here the production rule consisting of LHS and RHS. LHS produces RHS. The LHS is nothing but it consisting of only a single non-terminal. The single non-terminal is nothing but it is a capital letters. And coming to the RHS, RHS is nothing but it's a combination of terminals and non-terminals, and it can also have epsilon symbols also. So that is nothing but a production rule. So mainly the production rule is based on this V, T. V is nothing but the non-terminals which consisting of capital letters, and T is nothing but the terminal symbol, that is nothing but the small letters. So here in this production rule, the S is nothing but the starting symbol. In the production rule, if the first symbol or the first production, whatever it is there, so that will be our starting symbol. Yes. So each one we can call it as these are the productions, and this whole we can call it as a grammar, context-free grammar. So here this is one production. X produces AB, A produces AA or A, and B produces B. Nothing but here it is a combination of two productions. A produces AA, capital A, small a, or A produces small a. So for this production, let me check one string whether it is an unambiguous grammar or ambiguous grammar. So let me take here AB. AB is one AB, not AB. Yes, I can take AB. AB is the one grammar I want to generate. So for this string, can I generate an ambiguous grammar or unambiguous grammar? Let me check. So here the starting symbol is X. So X produces A. and B. X produces A, B. So A, I can replace it with A. Why? Because here I am having the first character is A. So let me check the A production. A can be replaced with either capital A or small a. So my string is A. And the next one is B. B is produced with B. So I can generate only one string. I cannot generate more than one string, more than one parse tree. For this string, I am going to generate only one parse tree. So that is nothing but this production is for unambiguous grammar. This production is for unambiguous grammar. So here, ambiguous grammar. So a context-free grammar, G, is pointing to V, T, P, S is ambiguous if and only if there exists a string in terminals that has more than one parse tree. Just now we have discussed that more than one parse tree is nothing but more than one leftmost derivation or more than one rightmost derivation or more than one parse tree. Then we are going to call it as a ambiguous grammar, where V is pointing to finite set of variables. These variables we can call it as these are nothing but non-terminals, and we can also call it as these will be in the form of a capital letters, and T is nothing but the finite set of terminals, and these terminals are nothing but the small letters, nothing but lowercase letters, small letters, or we can also call it as lowercase letters, and P is a finite set of productions. Where P is nothing but, I told not, it is a productions. It consisting of LHS produces RHS. LHS is on the left hand side and RHS is on the right hand side. LHS is nothing but it consisting of only capital letters, that is nothing but the non-terminals, and the RHS is nothing but it's a combination of terminals, non-terminals, and it's a combination, both it can be there, or it can also have epsilon also. Here a is a variable and alpha is pointing to, alpha is nothing but here where the production rule is in the form of A produces alpha. Let us assume A produces alpha. A is pointing to LHS, alpha is pointing to RHS. RHS can be V union T whole star. Nothing but V is nothing but it can consisting of variables or terminals, or it's a combination of variables and terminals, or we can also have epsilon also in the productions. S is nothing but the start symbol. In the production rules, we will be having n number of productions. The first production in the LHS, whatever that non-terminal is there, so that will be our start symbol. So this is nothing but ambiguous grammar. Let us see example. S produces ASB or SS, S equal to epsilon. For the string AABB, the above grammar generates two parse trees. We are going to generate two parse trees and we are going to check whether this grammar is ambiguous grammar or unambiguous grammar. So this is the production rules they gave. Two production rules are there here in the grammar, and we need to generate the string AABB is the string we need to generate. As I told that the start symbol will be our parse tree. To derive a parse tree, we should start it with the root node or nothing but we can call it as a start symbol. The start symbol in my production is nothing but the first one is my start symbol. So S produces, so I have ASB or SS. So according to the given string, I need to choose that production rule. So here the first one I'm having is A. So A, S, B, ASB. So what I have here, ASB. So the first one A is produced. So the next I have is A. So again I need to get A. So I have here non-terminal S. So I can replace this non-terminal with a double S or ASB or epsilon. So I need to replace it with ASB because I need to get the string AABB. So A, S and B, ASB. So here I got A, first A, and the second character A, and the next one I have B I got, and the next I got B. So I can replace these S with, S can be replaced with SS or epsilon. Epsilon is nothing but empty string I can replace. So see here, this is the one parse tree which I have generated. So for the same string, if I am able to generate one more parse tree, then I can tell that this is my ambiguous grammar. So let me take here S produces. I have taken first and this one I have choose. I can take the second one also, SS, and let me check whether it is going to generate the ambiguous grammar or not for the given string. So SS. So the first S I can replace it with epsilon or I can replace it with ASB. So let me replace it with epsilon. So the next one is The next S in the right hand side, RHS. The next one is S. I can replace this S with ASB or SS. I can replace it with ASB or SS. But I need to get the string. The first character is A. So A, S, B. ASB. So I got the first character A I have got. So the next one again I need to get the second character as A. So I need to replace it with ASB. 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 So I got the first character A, second character A, and the third character I am having is B, and the fourth character I have B. So I need to replace this S with something that is nothing but epsilon to end the string. So this is nothing but here also I got A epsilon A epsilon B, epsilon A epsilon B. Epsilon is nothing but empty B. So I have generated the string with different parse trees. So that is nothing but I can tell that the given string is the given production is nothing but it is a ambiguous grammar. Hence the given grammar or the hence the given the production rules following or follows the ambiguous grammar. The given string is a ambiguous. So because we are going to generate the parse trees, more than one parse tree I am going to generate by not applying the same condition. By different ways I have applied the parse tree and I have generated the same string. So it is nothing but ambiguous grammar. Let us go for one more example. E produces E plus E or ID. So I need to generate the string ID plus ID plus ID. So I need to check whether the given string is ambiguous grammar or not. So I told that ambiguous grammar is nothing but if it generates more than one leftmost derivation or more than one rightmost derivation or more than one parse tree, then we can call it as a ambiguous grammar. So here I am going to check by applying the leftmost derivation here. E produces E plus E. So as I need to start it with my start string, so nothing but E produces E plus E or I can take it as ID. But the given string I am having is ID plus ID plus ID. So I have operators are also there. So I cannot take this ID. I need to take E plus E as my first one, start symbol. E produces E and plus E. So let me take here E produces E plus E. E produces E plus E. So the next one again what I have here ID plus ID. I can write here ID plus. So I am replacing this one is with ID. I have replaced it with ID. So the first ID I got and the next I have plus. But one more I have again is ID plus ID. ID plus ID. So again I can replace it the second one with E plus E. E plus E. So these I can replace it with ID. And this E also I can replace it with ID. So I got the ID plus ID plus ID. ID, ID plus ID plus ID. So this is one parse tree which I have generated. So let me generate one more parse tree. So that is nothing but E produces. The first starting string I am having is E plus E. E plus E. So first I have replaced this one with ID. So now this time I am going to replace it with the E plus E itself. E plus E. So E I can replace it with ID plus ID plus ID. So how I am replacing? E produces E plus E or ID. So my string is having two plus operators. So I got two plus operators and I am replacing this E with ID. So ID plus ID plus ID. So I am going to generate for the same string two different parse trees. Then I can tell that the given grammar is also ambiguous grammar. So let us see one more example. Set of alphabets are given like a 0, 1, 9, so on, open brace, closed parenthesis and I. So star plus all these are nothing but some alphabets are given here and this is my production rule. E is producing I or E produces E plus E or E produces E star E or E produces. So these are some production groups. Productions are given here. So from these given grammar we are going to generate more than one ambiguous grammar or not. So see here the first leftmost derivation I have generated and the second leftmost derivation I have generated. By looking into these two I can tell that it is a ambiguous grammar. So see here the first one I am having is 3 into 2 plus I. I need to start it with my start symbol. The start symbol over here is E. I can replace this E with I or E plus E or E star E or open and close bracket E. But here I don't have open and close bracket E. So I'm not going to use this one. So the next one I can use is star symbol is there. So nothing but I can use, this is my symbol I can use. Or also I can use E plus E. Why? Because here I have the plus operator. Plus operator is there. So let me generate the parse trees for it. So E produces, so what I'm having, I'm not taking I. Why? Because I is consisting of terminals like 0, 1, so on 9. So that is the reason I'm not replacing initially with I. If I replace it with I, E produces I, then it will generate only one character. So now according to my string, I need to use the production rule. So E produces E star E. So for this, the leftmost derivation, I'm going to draw the tree. E produces E star E. So E star E. So what I have here, this E I can replace it with. I can replace this E with I. So I. E I can replace it with I or E plus E or E star E. E plus E I cannot replace. Why? Because initially only I have the star operator. So I cannot replace this one. I cannot replace this one. So I should replace it with I. So I is nothing but what it is having here 3. So it is replaced with 3. 3 star. 3 star. It's completed till 3 star. So the next one I have is plus operator is there. So I should replace it with compulsory with E plus E. I should not replace E star E. So E plus E, E plus E. So the next one is E I can replace it with I. E I can replace it with I. So I is nothing but what is the character I have? 2. And plus as it is. E should be replaced with I. So I is nothing but I can take the value as 5. So 3 star 2 plus 5. 3 star 2 plus 5. So this is nothing but the first string I have generated, first parse tree I have generated. So let us construct one more parse tree by with the help of these productions. If I can construct more than one parse tree, then I can tell that the given grammar or the given production is ambiguous grammar. So the next one I'm going to derive. I have taken here E star E. Let me take the one more production I have. The starting symbol E, I am taking it with E plus E. E plus E. So this E I can replace it with. The first operator I am having is star. So I am replacing it with E star E. E star E. So the first E I can replace it with. What is the next character I have? 3. So I can replace the E symbol. Nothing but the star symbol I can replace it with I. So I it is replaced. And the next I can replace it with 3. I is replaced it with 3. So the 3 star. The next E I can replace it with I. So I is nothing but it is pointing to the character nothing but 2. Integer character some 2 value. Because in the given string it is 2. The next E is replaced with I. And I is pointing to 5. So nothing but 3 star 2 plus 5. 3 star 2 plus 5. See, I have generated the 2 strings with different parse trees. See here I have taken here E star E and here I have taken E plus E. So I am able to generate that more than one parse tree. So that is nothing but here this grammar is nothing but the ambiguous grammar. Let us take one more example. E plus E, E star E, ID. So here I construct parse tree and check whether it is ambiguous grammar or not. So the star symbol in my production rule in my grammar is E. So I can replace this E with E plus E or E star E based on the given string. So let me generate here. E produces E plus E. E plus E. So the first operator I am having is plus operator. Plus operator is there. So E produces ID. I cannot derive E produces E star E. Why? Because the first one I have is plus operator. Then later on I have star operator. So that is the reason I am replacing it with ID. ID plus. So the next E I can replace it with E star E or E plus E or ID. But here I have two more characters or 2 more identifiers are there, ID into ID. So here the operator I am having is multiplication operator. So I need to choose E star E. E star E. E produces E star E. So this E is replaced with ID. Star. ID. So what we are going to get? ID plus ID into ID. So this is the one string which I have generated by with the help of these grammar or production rules. So let me try to generate one more grammar. If it is generating more than one parse tree, then I can tell that the given grammar is ambiguous grammar. E produces. So let me take the next one. E produces E star E star E. So the first one I have is the plus operator. So I need to derive this E. E produces E plus E. Here the first I have taken is plus operator. So that is the reason ID plus. But I have taken here star operator that is lying at the end. So that is the reason E produces E plus E. E is derived with ID and it is derived with ID and it is derived with ID. ID plus ID into ID. So we are going to generate more than one parse tree for the given grammar. So we can tell that the given grammar is a ambiguous grammar. So we can also check unambiguity grammar. So unambiguity grammar, for this grammar here I can do is I can check ID plus ID into ID. So here I can generate this one, but the my plus operator is coming this side and plus operator is multiplication operator is coming one side and the plus operator is going instead of the multiplication operator. So nothing but here we can eliminate this ambiguity by rewriting the grammars. We can also rewrite the grammars and we can eliminate the ambiguities also. Here we can also enforce the precedence star over plus. So let me take here ID plus I. E produces E plus T. E produces E plus T. So here the E is my start symbol. So I have taken E plus T. So here the first one I have the plus operator. So directly I am replacing this E. I can replace it with T. E I can replace it with the T. And this T I can replace it with F. T I can replace it with F. F is pointing to ID. So how I have generated here E plus T. So first I have terminal plus operator. So I have taken one type of tree E plus T. So E I should generate the terminal. So to generate terminal, E produces E plus T or T. I can take T. I have taken T. So T can produce T star F or F. So T star F I cannot take because the first I have is identifier. So I should replace this T with the F. So F produces open and closed bracket E or ID. So F is replaced with ID plus. So the next I have is T. So the T can be replaced with T star F. T star F. So this T I can replace. The next one I have is the identifier ID. So ID plus it's completed. So the next one I have is identifier. So this I can replace it with T produces F. T produces F. And F produces ID. F produces ID. So this F directly it is producing ID. ID plus ID into ID. ID plus ID into ID. So this is one grammar which I have generated. So let me try to generate the another grammar here. E produces the next one we can take it as E produces E plus T. E produces E plus T. So this E I can generate, I can replace this E with T star F. I can replace this E with ID, but again I am going to generate the same parse tree. So I need to generate one more parse tree. So to check whether it is ambiguity, whether I can generate the same grammar or not, same string or not. So T produces F, T produces F. So F produces ID, F produces ID. So this directly F produces ID and here the T produces F, F produces ID. So I am going to generate T ID star ID plus ID. So here based on these precedences, I am going to generate the two parse trees, but here I have generated the parse tree as ID plus ID into ID. But here I am going to generate ID into ID plus ID. So the difference here is the multiplication operator is plus is replaced with multiplication and here the plus is replaced with multiplication and here the multiplication is replaced with plus. So this is nothing but here by applying some left associative rules. So that is nothing but here it is a unambiguity grammar. I can generate for the given string only one parse tree I can generate. So that is nothing but it is a unambiguity grammar. So here we have discussed what is ambiguous grammar, what is a context-free grammar, and what are the types of context-free grammars like unambiguous grammar and ambiguous grammar. So ambiguous grammar is nothing but we can generate more than one parse tree or more than one leftmost derivation or more than one rightmost derivation, then we can call it as a ambiguous grammar. So coming to the unambiguity, if we can generate more, if we are not going to generate more than one parse tree or more than one leftmost derivation or more than one rightmost derivation for the given string, then we can call it as a unambiguity. Thank you.